And I think he hit it again to stop it.
All right, y'all. Now, what we're going to do today, we're going to finish up module 1. I've got some problems that I want to do, and then I'll open it up if we have time at the end. But my main goal for today is to get you out of module 1. I know a lot of you are like, I'm done with module 1, I don't need to worry about it. But a lot of you have done module 1, but you still have questions or don't know how you got out of some problems. To know whether you're in module 1 or not, we talked about this after the scheduled assessment, but I'm going to go over it again. You do the double drop down. You're going to drop down here, and you're going to drop down here. If it says that you're still in module 1, whole numbers and fractions, or if you're doing problems that say whole numbers and fractions, our goal is to be out of module 1 by next week. I want you in decimals and proportions. That's what we need to be working on in the month of September, decimals and proportions. So if you're already in decimals and proportions, that's where you need to be. Otherwise, we need to get you out of there. Now, what I did this morning and just now, I went in and I looked at what I call the Alex Pie report. I went into module 1 to see what are y'all struggling with. So I go into module 1, and anything that has 100% beside it, y'all know, y'all understand. If only 5% of y'all are missing it, but 95% of y'all have it, I'm not going over it. I'm going over anything that I see y'all are struggling on. 21% of y'all don't know that topic, so I'm going to go over it. Down here, we have 50% of y'all that don't know this. 13%, 54%, 41%. Those are the problems that I'm going to make sure that I go over. Okay? So, I just went in, like this one's 54%. I went in and these are the types of problems that I pulled. Word problems with fractions. So, that's what we're going to spend time on right now is the module 1 problems that y'all are still on the struggle bus with, even if you've gotten through it. Now, we talked about this last time. We're going to talk about it again just to make sure you understand it. If it says round so that there's only one non-zero digit, that means that you are going to round to the front number. So whatever that front number is, that's what you're rounding to. So it may be the tens place, it may be the hundreds place, it may be the thousands place. So the number that's behind it tells that front number what to do. If the behind number is 0 to 4, the underline is going to stay the same. If the behind number is 5 to 9, the underline is going to go up. So that red number is either going to stay the same or go up. That's it. So for this one, your 5 is going to tell the underline to go up. So that 7 is going to become an 8. Everything behind it turns to zeros. This 4, or this 2 tells the 4 to do what? Stay the same. Everything behind it turns to zeros. That's it. Now, I have some people say, well, why does it say that? It says you are rounding so that everything is a 0 except one number. Round so that everything, each number, so that it has only one non-zero digit. So you have one number that's not a digit and everything else is zeros. So when I go to my calculator, it's going to be 800 times 400. And there's your answer. So I have another one. It says round so that you only have one non-zero digit. That's telling me I round to the front number. So the 9 tells the 5 to become a 6. Everything behind it becomes a 0. The 8 tells the 5 become a 6. Everything behind it becomes a 0. Now, this is a division problem. So I'm going to type in 6,000 divided by 600. There's my answer, 10. Yay or nay? Now, prime factorization. Prime factorization is screaming factor trees. Factor trees. This is when we take the 60 and we break it down into prime numbers. Somebody give me an example of prime numbers. 3, 7, 5, 11, 13, 2, 19. So we're breaking this down into prime numbers. I don't care how you break it down. Give me two numbers that give me 60. Two numbers that multiply together give me 2 and 30. Somebody else could have said 30 and 2, or 3 and 20. Somebody else could have said 15 times 4. It doesn't matter. Now, if I go to the first tree, look at your 2. Do you agree that's a prime number? I stop. Break down your 30. You can say 2 times 15, 3 times 10, 5 times 6. It doesn't matter. I'm going to say 5 times 6. 5 is prime. 6 can be further broken down into prime numbers. You know you're done when you get to all prime numbers. 3 is done. This can be 2 times 10. 2 is done. This can be 2 times 5. 15 can be broken down and 4 can be broken down. So all of my trees look different, but when I compare the answers on the trees, 2, 2, 3, 5, 2, 2, 3, 5, 2, 2, 3, 5. So my answer is going to be 2 times 2 times 3 times 5. So as long as you break it down until there's nothing but prime numbers left, does not matter what your tree looks like. Good? All right, now, word problems are kicking y'all's butts. How do I know if it's addition? How do I know if it's multiplication? How do I know how to type it in? So, when you look at a problem, you have to be one with the problem. You have to understand what the problem's telling you. We have a road that's a 4/5 of a mile long. The crew needs to repave 2/5 of it. So in my mind, and sometimes when I come over to your paper, I'll draw the picture. What is this? The road. How long is the road? 4/5. And we need to pave part of it. So we are repaving 2/5 of the road. Now, if it's an addition problem, I'm going to say how much did they do in all. If it's a subtraction problem, I'm going to say how much more did they do. If it's a multiplication problem, I'm going to say I did 2/5 on Monday, 2/5 on Tuesday, 2/5 on Wednesday, 2/5 on Thursday. If it's multiplication, I'm going to do the same thing over and over. If it's a division problem, I have this thing and I'm splitting it up. That's division. Well, do you agree I didn't say how much in all? I didn't say how much more than. I didn't say I'm doing this on Monday, Tuesday, Wednesday, Thursday, and I didn't say I'm splitting it up. So this one you have to say, okay, what am I doing? I need to figure out what is 2/5 of 4/5. That's what I'm trying to figure out. What is 2/5 of this thing? Well, in math, what does of mean a lot of the times? Multiply. Not all the time, but a lot of times 2/5 means multiply. So for this problem, we're doing 2/5 times 4/5. 2/5 times 4/5. Now, y'all, a lot of y'all are getting so stuck in reading that explanation. It's going to tell you how to cancel and in this division how to flip. Type it in your calculator. 2/5 times 4/5 with them each wrapped up. Write it in simplest form. Math, enter is going to simplify it for you. There's your answer. There's your answer, 8/25. Let's do another word problem. A road crew must repave a road that's 4/5 of a mile long. They can repave 1/20 each hour. So, very similar problem, y'all. All I do is change a couple of words. So for this problem, I have a road that's 4/5. The first hour, I do 1/20. The next hour, I do 1/20. The next hour, I do 1/20. So I'm breaking my job up by hours. What kind of problem is this? Division. You're breaking your job into little baby sections. Now, here's the key, y'all. When you're doing division, the first number has to be the thing you are cutting up. The second number has to be the pieces you are dividing it up into. I have so many people that will call me over, and several of y'all did this today. You said, which number do I need to put in first? When it's whole numbers, y'all aren't worried because y'all say, oh, the big number goes first. When y'all are doing fractions, you freak out because you don't know which number needs to go first. Oh, undo. Move this so it was kind of off the screen there. So when you're doing division, the first number is your thing. The second number is how you're cutting it up. So my first number is going to be the road, and my second number is going to be what I'm doing each hour. If you type them in backwards, you're going to get it wrong. So my first number is my thing. My second number is how I'm cutting it up. So if you don't type it in that way, and y'all, in the explanation they're saying, oh, you need to divide it, change division to multiplication. No, you don't. Your calculator knows how to do that. That's why it costs so much. Now, I have people that freak out and say, but Miss Cooper, it says write in simplest form. Every single one of y'all's problems are different. That's telling you that if your answer was ugly. Your answer's not ugly, so there's no need to simplify it. So if your answer was a decimal, then yes, I want you to simplify it. But it's okay to have a pretty answer. It's okay to have a whole number. So it's saying, how long is it going to take to repave the road? 16 hours. If I'm doing just a little bit each hour. All right, let's look at some more word problems. A pipe is 10 feet long. We're cutting it into pieces. Add, subtract, multiply, divide. We have a pipe. We're cutting it into pieces. Divide. What is that? It's not a blunt. What is it? This is a pipe. How long is my pipe? 10 feet. What is that? Scissors. Use your imagination. We're cutting into 2/5 pieces. So we're taking this pipe and we're dividing it into sections. So this is a division problem. So now that we know it's a division problem, we have to figure out what's going to be divided by what. My first number is the thing I'm cutting up. So what am I going to have for my first number? 10. My second number is what are the pieces I'm cutting it into. So when I type it in my calculator, 10 does not need to be wrapped up. It's pretty. So 10 divided by 2/5. It says write it in simplest form, but it's not ugly, so I don't have to. How many pieces can I make? How many little pieces are going to be made for that pipe? 25 pieces are going to fall from that piece of pipe. All right. Lucy bought 30 pounds of dog food. She feeds her dog 2/3 of a pound for each meal. How many meals will the food last? I actually do this. I have 2 dogs that are 80 pounds apiece. So we feed them the same amount of food every meal. Once a day, they get the same amount of scoop. So, what is that?
Dog food.
That's my dog food. I bought 30 pounds of dog food. What's that? That's my scoop. So every time I scoop is 2/3. So I want to know how many days is this dog food bag going to last me? So is it add, subtract, multiply, divide? I'm taking that bag and I'm dividing it into daily scoops. So, because it's a division problem, it matters the order in which I type it. The first number has to be the thing. What is my thing? The dog food. And I'm dividing it into scoops. So what's my first number? Divided by? That has to be wrapped up. So if I go to my calculator, I have 30 pounds, and I'm dividing it by 2/3 of a scoop. How long is this dog food going to last me? 45 days. A group of 40 people will plant a field that's 5/8 of an acre, assuming that we split the job equally. Add, subtract, multiply, divide. Divide. So, we know that this is a division problem. The first number is the thing that we're splitting up. What are we splitting up?
The acres.
The acres. Just because 40 is my bigger number doesn't necessarily mean it's my first number. Draw you a picture. What is this? That's my field. It's 5/8 of an acre. So we go out to this big field and I take my class out there and I say, I'm going to separate the field and you each are going to be responsible for a little area. So the thing that we're splitting up is the field. And the thing that I'm dividing it between is the people in the class. So this time, the smaller number goes in the front. So it would be 5/8 divided by 40. See the difference? So in my calculator, I'm going to do 5/8, which is my field, divided by 40 people, because I'm splitting the field among 40 people. Now, you're going to look at that answer and say, that doesn't make sense. This means that each person is going to watch 1/64 of an acre. Because if you have a land and you have 40 people, each person's not going to have that much spot to watch. We cool? Questions? All right. Let y'all read that one.
A bag of rare spice.
Read it to us.
A bag of rare spice that weighs
You're good? You got it?
will be split equally among 18 people. How much spice will each person get? All right, we splitting up the spice.
Okay, we're splitting up the spice. So that's our thing. So if we had to draw it, and sometimes I have to draw it. This is my spice. So that's 2/3 a pound of spice. So let's say I go to India and I bring y'all back a sursi. I bring y'all back some spice. So the thing that I'm splitting up is my 2/3 pounds of spice. Who am I splitting it between? 18 people. So when you read a division problem, you have to say, what is the thing that I'm splitting up, and how am I splitting it up? So this one is going to be 2/3 divided by 18. Simplest form is just in case it's ugly, and that one was ugly. So this means each person gets 1/27 of a pound. Well, y'all, I brought less than a pound for all of y'all. So y'all each gonna get a little pinch. Little something, little something, because I didn't bring a whole lot. Amanda made a shirt using 1/4 meters of blue fabric, 3/5 meters of red fabric. How many more meters of red did she use than blue? Did I split something up? No, so it's not division. This is subtraction. How many more is screaming that you need to subtract? Now, is it going to be 1/4 minus 3/5, or is it going to be 3/5 minus 1/4?
It doesn't matter.
All right, Mr. Parnell. If you go to the bank
Yes.
and you have $20 in the bank and you take out $5,
Okay.
are you good?
Yep.
Yeah, you got $15 left in the bank, correct? If you have $5 in the bank and you take out $20, are you good?
Can't take all that.
You're gonna bounce some checks and you're gonna get insufficient funds.
Okay, so it's, okay, 1/4 minus 3/5.
Why?
Because one is like a whole, I can't explain it, but I know that 1/4 is bigger than 3/5.
How do you know that?
Cause
You
it's,
just know?
I don't know how to Oh, never mind, man. I'm wrong. I'm sorry.
Okay, raise your hand if you think 1/4 is bigger. Raise your hand if you think 3/5 is bigger. Raise your hand if you don't know. Raise your hand if you don't care. All right, there's a cut. You have to have, when you do subtraction, the bigger number has to be in front. Because we've just learned that if you don't have enough money in your bank account, you're going to be bouncing checks and you're going to have insufficient funds, and we don't want that. So subtraction, you cannot flip-flop. Vera, what is the property? Only Vera. What is the property when you flip numbers around? When you talk back and forth, what property is that? The commutative property. Addition, you can flip them back and forth. Multiplication, you can flip them back and forth. Subtraction and division, you cannot flip them back and forth. So addition and multiplication are commutative. The commutative property says you communicate back and forth, you can flip them back and forth. Subtraction and division are not commutative, okay? So we have to know which way to put them, so we have to know which one's bigger. Now, there's two ways to determine which one's bigger. I just heard the girls helping out Mr. Parnell. If I have 2 Snickers bars, and I divide the first one into 4 pieces, and I shade one of them, do you agree that would be 1/4? And then to do 3/5, I would divide it into 5 pieces and I would shade 5 of them. And my question would be, which one is bigger? Which one did I eat more of? The 3/5, because that one shaded more. This one I only ate that. This one I ate that. You also could go to your calculator and do 1/4, 3/5, and see which one has the most change. This one has 25 cents, this one has 60 cents. So how am I going to have to write it so that I won't have negative money? I'm going to have to use this one so that I won't have to, this is going to be my big number minus my small number. So if I go to my calculator, I'm going to have to do 3/5 minus 1/4. And it says simplest form. And remember, every time I do math enter, it automatically gives it to me in simplest form. So my answer is going to be 7/20. Cool? How do we know that it was subtraction? How much more? How many more? That's screaming subtraction. You walk 1/4 miles to the clothing store, 1/5 miles to the shoe store. How much did you walk in all?
Okay, that's an addition.
In all is addition. When you go to Walmart, they total or they add up in all. Does it matter if I do 1/4 plus 1/5 or 1/5 plus 1/4?
No, ma'am, that's not happening.
Because what property says it doesn't matter?
Addition
The
property.
commutative property. Both of these are going to give me the same answer. So in my calculator, 1/4 plus 1/5. And then I'm going to do math, enter, 9/20. No common denominators, don't have to do that. Calculator does it for me. Now, some of you are still on the struggle bus with this one, which is fine, okay? Some of you got through it, but don't know how you got through it. There's two different ways you can do this. My goal is to figure out what is the shaded part of the circle. So the way that I do this problem is I start out with 1 to represent I have one whole pie. So the 1 represents that I had a whole pie. Minus represents that I gave away 4/7. Let's hush in the back. Minus represents I gave away 1/3. So I started out with a whole pie. I gave away 4/7. I gave away 1/3. So do you agree that if I had a whole pie and I gave that away and I gave that away, I'd be left with the blue slice? You with me? So if I go to my calculator and I say, hey y'all, I had a pie and I gave away 4/7 and I gave away 1/3, that's the blue piece. And then if I do math, enter, this represents the blue piece. That's how I do it. Now, I have some people say that I read how they did it in Alex, and that's not how they did it in Alex. So let me show you, in the back, let me show you how Alex does it. What Alex does is it says, let's add up these two pieces. Bless you. 4/7 plus 1/3. 4/7 plus 1/3. So, I'm going to do 4/7 plus 1/3. Now, does that answer represent the blue part? No. That answer represents this piece. So when I do math, enter, 19/21 represents 19/21 represents all that up there. So if you put in 19/21, you're not telling them this piece, you're telling them this. So that's saying if Mama had 21 slices of cake, 19 are gone. I don't want to know how many's gone, I want to know how many's here. So if 19 out of 21 are gone, how many are here?
2.
19, 20, 21.
2.
So what's left is going to be, let me do a different color. What's left is going to be 2 out of 21. So you can find the yellow part, but you just have to remember the yellow part's not what you're looking for. So what if I had something where I said find this part, but when I added up this part, it came out to be 13/17. What would this part be? 4/17. So you can do it this way. A whole pie minus that is going to give me the blue part. Or you can say, let me add up those two pieces, and then I can find the other piece by saying what's left over. Does not matter to me. All right, let's do another word problem. How many gallons of gas did he use combined on the 2 days? What kind of problem is that? If you combine it, you are adding. Now, I have so many people who still do not listen in here because they are talking or texting or paying attention to other things. They have forgotten how to do mixed numbers. How do we do mixed numbers in our calculator? Parentheses, 3 plus 1 over 2. Close it. And then 3 plus, divided by 8